What is a macro? What the heck is a macro? Well, it's really stupid. It's really simple. It's basically just a function that goes from code to other code. Not so
This
bad.
is too advanced. I think it's actually just a stream of bytes to a stream of bytes. That's how we should view all macros.
No, I mean, real, and in some languages it is. In Rust it
Yeah.
is. In Swift it is. Um, Code string to code string is a good way of thinking about it to start with. But of course, it's really in Scala at least, and probably in Scheme too. Well, everything's in an AST unless you're coding in ASTs. Uh, but in Scala, it's an abstract syntax tree to an abstract syntax tree. And what is an abstract syntax tree? Well, so here's our little example. We write all of our code as giant text files, essentially, big blobs of bytes. It's very unstructured, deeply unstructured. And if we're going to actually turn that into, machine code down the line, do something interesting with it, it's great if we can extract some structure out of that. And that's where these abstract syntax trees come in. We take our code string and we try to turn it into something more reasonable that we can operate on in our host programming language. So here, I wrote this a while. These slides are a little old, so it's Scala 2. Disgusting. There's a seal trait here instead of a nice Scala 3 enum. So apologies for that. But we have a seal trait of our abstract syntax tree, and it has two cases. It's either an int literal or it's this add node. So if we were to parse our code string, our file, this is what compilers do. It's usually like the first step in the compiler is to find all the source files and then parse them into this structured format. If we were to parse this file into an AST, it would look like this probably, an add of two int literals. And then this could get further processed by our program. We could add another node to our abstract syntax tree here called a variable or an identifier or something like this. And this would allow us to write x plus 10. And x would be parsed as a variable. It clearly can't be an int literal. And it's just some example ASTs. And what the compiler does from this point on is operate on abstract syntax trees, transforming them in a variety of ways, eventually maybe having other AST representations, different intermediate representations that are other trees that do other things, adding things to these trees like types after it infers types, transforming them. One transformation is optimizations can be performed statically on your program. So here we can realize that, hey, if we have a tree at compile time that is the addition of two literals that we know the values of at compile time, well, why don't we just sort of actually perform the addition at compile time and embed in the program there an int literal of their sum. And that's actually an optimization that compilers do that's known as constant folding, which is pretty ho-hum and sort of table stakes, and it just speeds up your program. And why would you have to at runtime add 10 plus 10 if you could do it up front once? And so oh yeah, so if we optimize the parsing of 10 plus 10, we're going to end up with the int literal 20. So in some sense, a macro is an AST transformation just like optimize, except it's not built into the compiler. The compiler gives you, the user, the ability to write these transformations. And there's a bit of a ritual, and that's kind of where the complexity comes in. Like you can't just grab a hold of any abstract syntax tree and just throw the things around. You are not the compiler. You could do that if you were writing up maybe a compiler plugin or something, but macros are a very specific sort of way of doing this, and we're going to get into that today. Eventually. Well, first a preview here. So in normal Scala, let's contrast. In normal Scala, you write definitions like this, and you operate on the resultant values of expressions. So when someone calls debug with the word hello here, value inside of the body of your function is going to be that hello string, which makes sense. And you could print it out, make it uppercase, reverse it, whatever you want to do. If they've had first extracted the argument to a value, that does not change the body of your function here. Right, that would be weird if it did. No, it's still going to be hello. It's going to be the resultant value of that expression. If you did a concatenation of some exclamation points, well, you're going to get the resultant value of that expression in your body. It's first going to fully apply the arguments, and then you're going to get the result of that, and so on and so forth. I think that's kind of our normal expectations, sort of pointless to even elucidate here. But In macro Scala, it is very different. We get we operate on the abstract syntax trees of our expressions. So here, we don't get a string, we get this thing called an expr of a string. And an expr is really just an abstract syntax tree that's given this type of what it might evaluate to if it were evaluatable. So it's just this phantom type parameter that tells you what the AST represents. So if you call this debug, this macro debug with the string hello, you would see something like this is a literal hello. It's an abstract syntax tree, just like our literal int literal from before. This is a literal of the string hello. If you extracted it to a value, like this val my string equals hello, this is going to be a very different abstract syntax tree. It's going to be an identifier, and you're going to get the name of the identifier. Notice, in this case, you will never get the underlying string representation. You do not have access to hello anymore. You just have access to the code that was called, that was sort of your macro was called with. And then
I
it's
think
this is
this is sort of mind blowing when you first start playing with macros because initially it seems like, oh, this is obvious, right? But the weird thing is your macros, let's say capturing group or like what it's capturing can be highly dependent on how the user calls your code. And so I think this is why you need such good APIs for macros because you need to capture, I mean, most macros need to capture a specific state or specific value. I guess I should say value, right? And what it captures is very important to the behaviors of the macro.
yeah, it's important. It's a tricky thing to get into your head if you're used to just normal runtime programming. This that there's this distinction between compile time and runtime at all, and then the fact that if you're designing a library to use macros, you have to have a pretty good understanding of what's even available to you. And I kind of am used to it now because I've done so many of these, but I remember at the beginning very shaky footing to figure out, wait, what do I actually have access to when? When do I have the value? When do I not have the value? It's just, oh, I don't actually have the value. I just have an identifier, but I'll have the value at runtime. So to be able to thread these two timelines together in your mind and generate something useful, it's a fun challenge, and it eventually does become second nature. But at the beginning, it sucks and it's confusing because we're not used to doing this. Uh, Similarly, if we were to have this macro get called with my string plus bang, 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 just like before, we're going to get this much more complicated abstract syntax tree passed in. So you see there's the select. We're selecting the plus function on our my string identifier, and then we're applying that function to an argument list that has a single plus 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 literal. You eventually get used to the shapes of Scala syntax trees, but at the beginning, once again, very confusing. So there you see my string, there you see plus, there you see the select is selecting that plus, right? Plus is an operator on string, and you could just have sort of an infix notation, but really that's just syntactic sugar. It all gets parsed the same way, and like this. So craziness. And then of course the whole thing is that. And then the last bit here of this mini slide presentation is in normal Scala. In normal Scala. Oh, by the way, if anyone has joined late, you can try the AI companion to catch me up. Apparently that's a thing. What is it going to say, I wonder? Catch me up AI companion.
I think you're
Oh,
acting
and
like a Zoom shill.
I am a total Zoom shell. No, I hate Zoom so much, and it's just
If you
so
hate
weird
it,
that they
then
have
why'd you
these
host your
features.
webinar on it? I think this is a terrible mentality.
I don't know how else to host a webinar. And this isn't even a webinar because that costs like $50 a month. This is just a
Oh,
normal
you're
meeting.
right.
So
Just a
anyone can
meeting.
do.
This is a meeting with very important people. So
Yeah, yeah, definitely. Um, wow, this is hilarious. Okay, anyway, sorry. You can't see that AI companion thing, luckily. Normal Scala. So in normal Scala, back to normal Scala, we return new values based on our inputs. So, we were passed in some string, we're going to return a new runtime string value. We're concatenating value to the end of this other string. And we're going to get back a string. Now, in abstract syntax land, at compile time, macros, we return new abstract syntax trees based on input abstract syntax trees. So once again, we're working with trees code strings with structure uh, versus actual runtime values. So we're rewriting code. So new ASTs based on input ASTs. Animation. Okay, so we could return this. This is a valid implementation. And I want to do this just because this is important to the semantics of macro definitions in Scala. When you call a macro method, one of these macro definitions, this is how it works. You are given the abstract syntax tree of that is passed in as the arguments. So for each argument, you'll receive its abstract syntax tree, so that this will turn into that whatever apply of select up to uppercase on a string literal. That's what value is going to be. And then whatever this macro method returns, the resulting expression, it's going to actually delete the macro invocation. The macro invocation never happened and replace it with the resultant value. So this gets erased and replaced at compile time. It gets expanded. In this case, it's condensed in a way, but it's called macro expansion with the actual expr that macro returns. So this is how you can fit into the compiler pipeline. It's this sort of principled way that the compiler, for a moment, lets you as the user operate and transform syntax trees. But you can only transform the syntax trees that you're passed when someone calls one of your macros, and the only output you can affect is quite local. It's going to replace that macro method call with the resultant abstract syntax tree. And in this case, it's like the identity function. We're not transforming it in any way, but we could transform it. For instance, the whole point of why this is called a debug macro is that we could match and see, hey, is the term an identifier? Like, was it just one of those bare variable names? And if so, we could match on that term, match on that piece of abstract syntax tree, get the name out, which is a string, and then create a new abstract syntax tree using this magical sort of string interpolation-like syntax that works. It's like string interpolation for abstract syntax trees that Scala 3 has. And you can create a new...
Which is important to know that it only works somewhere, some places, right? Like this is not, that means it's beautiful, but it's not everywhere, yes?
It's not, you can only call this special quote syntax inside of a macro definition. And this is slightly elided. I've simplified this a bit. We would have to have a few more imports in a real macro, but just to get the conceptual idea across here. But yes, okay. You couldn't call this in just any normal code. It has to be in this macro world. And basically what we're doing here is we're interpolating into this abstract syntax tree the string, basically a string literal that is going to be equal to whatever the name of that identifier was. And then we're not actually doing this concatenation at compile time. This is inside of our quote block. So we're sort of building the abstract syntax tree of the idea of creating this concatenated string.
And so what is this? I think it might be helpful to highlight what this expr thing is inside the quotes, because I think it makes sense. Like we get some AST in as a value, but what does the expr do on sort of the output here?
Yes. So this expr, so it's a little complicated here. We have jumped a little ahead with this example. And hello, Flavio. Good to have you amongst us. Let me know if you need any catching up here. But so, one minute, check the chat there. Hey, yes, hey. So what's happening is we're getting in this value, which is something like an ident of foo. Val foo equaled some string, and you passed in foo. So that's going to be an ident of the string foo. So name here is a string literal foo at compile time. And what we want to eventually do is create a string that is foo equals and then the actual value of that string. So we can debug that in a print line statement. Because usually if you print line foo, you're just going to get hello or whatever the string value was. And it can be nice. A very simple macro use case would be to prepend the identifier name. So you don't have to do that. So many times when you're print lining things for debug purposes, you're going to say, foo equals and then interpolate the value foo. Cut out the middleman. The compiler knows the identifier name, and you can sort of do that automatically. So what we want
and
to
it
do
gets
is,
updated. So when you change your code, the debug would be updated, which is the valuable part, right? Like sometimes you forget to change your prints or whatever, so it's useful.
and it's one of the best parts about macros in general, is that you have this single source of truth, which is the structure of your code, and having to sort of inscribe things redundantly, you get bugs and mismatches. So being able to use the identifier as a single source of truth, or being able to use the structure of a case class as the source of truth for certain things, and derive um, particular patterns at compile time, JSON, codecs, etc. So we're building up an abstract syntax tree here with this quote syntax. So basically everything inside of here, it's it's building the abstract syntax tree of that thing. With some caveats, we have this $sign, and it's very much like string interpolation. Like if you understand string interpolation, I should have had this in this example. It would have helped a little bit. Um, this would be the letter S. These are double quotes, and these are still $signs. You're interpolating, instead of interpolating other strings into some string literal, you are interpolating other expressions, other abstract syntax trees into sort of an abstract syntax tree literal. It's kind of what the quotation syntax allows you to do. And very similar semantics, just a little more complicated because ASTs are more complicated than strings. And so here we're taking our value, which was an abstract syntax tree of the identifier foo, and we are matching on it, getting the identifier's name out. And then what this expr thing is doing, it can take certain types, certain primitive types like strings, and it turns them into their abstract syntax tree equivalents. So if you put a string in here, it's going to turn it into a string literal abstract syntax tree node, which is exactly what we want to embedded in this position, because we want to concatenate the string, which is foo equals, and then whatever the value of foo is, as it is a string.
I think the
In this
important point
in
there
this
is that
case,
you can't just throw a string into this AST. You need to be able to throw in more AST, right? So the expert is sort of
exactly,
our backdoor way to say, hey, we already know the value. We're going to give you some sort of AST that has the value in it.
exactly. It's taking this normal Scala string, and expert turns it into an abstract syntax tree representative of that string. And you can do this with any type that has this toexpr case class, or sorry, type class implemented for it. And you get these by default for primitive types. So string will turn it into a string literal. If you do an expr of an int, it'll turn it into an int literal, etc. And so what we're eventually going to get is, I'll show it actually. I should have done this before. So if we call debug with hello, what's going to happen is, well, this literal is not going to match on ident. It's just going to match on the second case, and we're just going to simply return that value, and hello becomes hello. Not very interesting. But if we've pulled it out into an identifier, what the heck? Well, now what this macro is going to receive, it's going to receive the identifier my string, and therefore my string, well, which is actually I should have shown this as a in double quotes. This is a string in this case, uh, is going to match here, and so what we're going to get is my string plus equals is the space plus my string. So notice here we're also interpolating, we're splicing in this expr, which is basically just taking that initial expr and just taking that abstract syntax tree of ident my string and putting it in this position, ident my string. So it isn't doing string concatenation or string interpolation, it's doing abstract syntax tree interpolation. And explosions of the mind, I'm sure if you've never done this before, this is a little horrifying and confusing. Um, I will pause there in case there are any questions or extra thoughts, or if Adam, you would like to state everything more lucidly.
No, I think this is just, it's fun here. I think I'm excited to see something that we can build more complex or useful.
Okay, let's do it. So yeah, that was the macro overview, which took slightly longer than I thought it would, but that's how everything I do occurs. So let's go back to the code zone. Cool. So yeah, that was the check or division, I guess. I don't know how I did that. Icon. Oh, I've changed my Option V is now my the button that opens my code editor. So I cannot do a check symbol. I used to love to just drop in a check mark, but there we go. There's one chat message. Not sure I understand. Can I take an ident as the parameter and Scala will place the value in the generated tr tree directly via the identifier? Maybe we should look into this example a little bit actually. Just because I've already done this. Like let's implement this for real. Let's do this debug thing in code and we can explore that. Um, so I'm going to, hey, go into Stubby. We'll get to Stubby. But I think this is maybe more useful and interesting. So I'm going to get some stuff going here. I actually have a separate macros file that I set up. So yay. I'll throw debug in here and we'll work on the boilerplate and get everything set up. So when you're writing a macro in Scala, and I hope this size is decent. When you're writing a macro in Scala, you're going to need to do a couple things. Oops. First, import this. Very important to import this scala.quoted.star. And now we can start writing macros. And there's a bit of a ritual you'll get used to. Every macro sort of has at least two parts. And I don't really know if they have names. I'll call them sort of the macro definition and then the macro implementation. So the macro definition, this is the thing that the user actually calls. So this will be something like debug. You're not going to see the word expert in it at all. It's going to take in some.
This is the face of your, right?
The face of the macro face, and then this is the macro sinew and guts and whatever's behind your face, sinuses, the revolting.
Hopefully we say body. Let's just call it macro body.
Yeah, okay. So down, not back. Okay, that makes sense. I was thinking anatomy book or something. All right,
that
so value is a string, and this is the type that we were going for here. Okay. And so just some more boilerplate. Macro definitions always need to be inlined because the call is going to get inlined. And you can actually use that modifier in other ways. I know you know about that, Flavio, but macro definitions are always going to be inline. And and then the body is always going to have to be this splice, a splice of a call to a macro implementation. So usually I'll say something like debug impl. And what you're going to do is essentially propagate over all of the arguments, except not just like that. You're going to put a little quote in front of them. And for now, you can just treat this as boilerplate, but I will try to explain it. It is sort of the inversion of what we were looking at below, where you had a quoted syntax and you were splicing in exprs. Now you're splicing into sort of your program something, an abstract syntax tree. So it's like you're taking this AST and it's kind of beautiful in a way. You're splicing it into the AST that is your entire program. This is a beautiful idea. Like everything is an AST. That's what we're writing. We're writing ASTs in text form. And by doing this, we're able to splice this in here. And only in this very particular way can you write a macro. Like you can't have anything else in here. I can't do print line hello. A macro definition has to be an inline def whose body is precisely one and only one splice. So the beauty is a little bit forced upon us and a little bit contrived, but still, it's a nice idea. You can't just splice in exprs anywhere you want willy-nilly. But it's sort of a beautiful metaphor. And then the other half of this is that these values, these are values. They're not ASTs because we're living in the world of our program. We don't know the difference between these worlds of runtime and compile time. And so in this splice, where we want to sort of operate on these values as abstract syntax trees, we quote them. We like get the value and we turn it into an abstract syntax tree. Once again, not really magical, or kind of magical and kind of built into the compiler. You can't just quote any old code anywhere. It has to be in this format. But anyway, this is the ritual of the macro definition. You need that inline keyword with a splice body, and you need to quote all the arguments.
Do you need to inline the parameters to the function?
You optionally can inline the parameters, and you don't always have to. In this case, we probably want to. if you want to, and we could take a look actually at the difference between inlining and not inlining the parameter. In this case, we will. If you ever basically, the rule of thumb is going to be if you want to sort of investigate or match on the structure of the AST of that argument, then yes. Sometimes you don't. Sometimes you just want to interpolate it somewhere and you don't care about breaking it apart. So you don't need to do that. And okay, so that's the first half. The second half is the implementation. So let's take a look at this. So def debug. I have lied a little bit here. Obviously, nothing is compiling. So one thing you'll need is the macro implementation essentially mirrors the structure of the face slash definition, except that everything is wrapped in expr. So we're dealing in this world of ASTs. So string to string is now expr string to expr string. And also, we will need to using the quotes. We must using quotes. And this is what brings into scope all of the knowledge of the state of the compiler at this time. So whatever this quotes thing is, it knows the types of values. It knows other definitions in our system. It knows we can look up, the methods of a trait. This is the compiler context essentially, and you can think that maybe this is sort of brought into scope by the splice for us somehow magically. Do quotes spark joy? Yes. And then the last annoying step, finally, is quotes reflect star. You have to import this thing, and you just have to
Everywhere.
it's
Basically everywhere. This is probably the most annoying thing about macros is and the more functions you write, the more you get just frustrated by this import.
Yes, every impl, I should add the word impl here. Every time you're dealing with exprs and you're writing functions on exprs, you're probably going to want to using quotes, and you're also probably going to import quotes to reflect star. So this is just part of the boilerplate. You get used to it. But it's not ideal. So there's that. Okay. So now it looks like it's compiling. I want to take a look though. One thing to know about macros is you cannot call them in the same file that they're defined. So we're going to jump back here, and I'm going to say debug hello, and maybe I'll say at main def main debug hello, and then we can spin up the terminal, open up SVT, check out stubby from scratch 00001. So we can record up to 999,000 episodes. Oh, that's not nine. That's no, just 10,000. But we can wrap around and go negative as well. So okay. So yes, there's some tests are running. So this seems to be running. It's hard to say because this just returns a string. So let's print the string. Result is string. See, there I'm doing it. I'm doing it already. The thing we want our macro to solve. I will. Yeah, let's take a look. There is no main class detected. I don't know if that's true. I think this exists. Project core run. There we go. Result is
there you go. Nice.
So our macro is returning the expr, which is just hello. So not very exciting at all.
What's going to happen if you recursively call debug is the real question.
Recursively? What does that even mean? Like debug,
so
debug?
Obviously, we don't want to, yeah, no. Assign to a
debug,
result
debug?
value. We're assigned to result. Come
on. Okay, assigned to result.
In this, yes, called debug in here. No. We got to call print line debug result.
Print line debug result. Oh, I see. I see what you're going for. You want it to actually work. You want it to work, don't you? So it's not working yet. It's not working. We did all this work, but it's failing. So why? And this is my number one macro implementation trick. It's to use this report module, which we get into scope from quotes.reflect, and then write error and abort and give it a string. Why? Because it'll fail and it will give you a nice error message. And sometimes when you're working on macros, if it successfully compiles, it will be cached. That file will be cached, and then if you make subsequent edits to the macro, I think you're changing things, but you won't see anything because you have to make an edit to the actual file where the macro was called. Now that I don't think that will happen here, and maybe they fix that, but this is my old fear that's been instilled into me, is to just blow it up, debug like this. And so let's take a look at what value is. So value is, if I just do this, we'll see that it's a runtime impl, expr impl, whatever. So completely opaque, just like a lambda. Not great. There's a couple things we can do. One is you can call show on it, and then you'll see that it says the word result, or no, it says the word result. So that's interesting because it seems like we are getting that information. But then if you really want to see what the underlying tree is, you have to say as term. And this will get you the abstract syntax tree. And we can see here, unfortunately, that it's not so simple. It's been wrapped in this thing. It says inlined. And that's just some extra wrapping that occurs when values get called in macros. Like your top level expr is almost always going to be wrapped in
Oh, we didn't
that.
inline it. The parameters are inline. The macro is a lie.
I know we didn't even inline that argument, but I think for some reason it's still happening. And it's annoying. And there's a couple things you can do. One is we can pattern match on that. Another fancier trick is to use this method, which is completely obvious. Can you guess what it is, Adam?
No, no.
It's underlying argument.
Of course, of course. I
Duh.
thought you were just going to use, value.show as our full macro, basically.
Oh, that would have worked actually. So that should help us. Oh yes, if I do it here, because I'm failing. So as term underlying arguments, we'll see that it removes the inlined wrapper. And so now if I do this, we should ideally get result equals hello, which is exactly our thing. And if I do triple equals, we'll see that it is indeed doing what we want. So we're matching on the ident, grabbing the name out, which is a string, turning it back into, and I can make this even more clear by saying name expr equals expr name. And we'll see that this is of type expr string, whereas of course name is just a type string. And I can't just quote or splice in string because it's expecting an expr, but we gave it a string. And so that's why we want this name expr here. And if I want to, I could say report.error and abort, name expr.as term. And we'll see that it is a literal constant result. So it is
Hey,
whatever. It was at this point that we were assailed by internet trolls in a so-called Zoom bombing. And many inflammatory remarks were made by this false James Ramos and other imposters. So the meeting ended with much chaos and screaming. We will be back next week to finish this off. Hope you enjoyed everything so far, and have a beautiful, beautiful day.